Okay, so in 101 we're asked to solve for x. Here the trick is we've got to notice that these two angles are congruent. Therefore this is an isosceles triangle, and the sides opposite each of these angles must also be equal. So therefore 8 equals 2x plus 4. So these are facts that we just need to remember, because without knowing these facts we'd have no idea how to solve this. So isosceles triangles have two angles that are congruent, and opposite each of those angles the side length are exactly the same. So therefore we can start off with 8 equals 2x plus 4, and when we solve this we end up with x equals 2. So that's our answer for number 101. Alright, so 102 asks us to name the polygons with the given number of sides. So 3 would be a triangle, 4 would be a quadrilateral, not a square because it could be a rectangle, rhombus, parallelogram, trapezoid, could be any of those, but if it's got 4 sides it's definitely a quadrilateral. 5 would be a pentagon, 6 would be a hexagon, 7 would be a heptagon, which some people call a septagon, but heptagon is the original name. 8 would be an octagon, 9 nonagon, 10 would be a decagon, 12 would be a dodecagon, I'm pretty sure, and 20, and in fact 13, 14, 15 and so on, what we would do is just call them by the number and then dash gon, and that would be the answer for 102. Alright, question 103 through 107 we're asked to fill in the gaps, in the blanks. So in a blank, rectangle or rhombus, the diagonals are congruent. Well, let's think about this. If you've got a rectangle versus a rhombus, we know in a rhombus all these sides are the same. We know in a rectangle these two sides are the same and the top and the bottom are the same, but this is talking about the diagonals. So firstly we need to know what a diagonal is. A diagonal is a distance from one vertex to the diagonally opposite the other. So here, what do you think just by looking at them? It looks like the rectangles are congruent, right? Like this one, top left to bottom right, is the same as bottom left to top right. Whereas here you could kind of imagine like that the distance between this point and this point might be a little smaller than the distance from here to here. So in fact the answer is rectangle. Alright, that was 103. 104. The diagonals are perpendicular, so this means at 90 degrees. This is the sign for perpendicular in a rectangle or rhombus. Well, let's go back to our couple of pictures. Rectangle, stretch this out. Now here this looks obtuse, this looks acute, so that doesn't look like a 90-degree angle like this would look like 90 degrees. So let's check, that's a rectangle, let's check the rhombus. If each of these sides was congruent, does this look like they intersect at 90 degrees? It does, and in fact that's one of the definitions of a rhombus. The diagonals intersect at 90 degrees. So we're going to write that in there. That was 104. Okay, 105. It's talking about opposite angles are congruent in all. Well, polygons is a weird one because polygons are any shape with straight sides that are closed figures. This would even be considered a polygon. So when we're talking about opposite angles, the angles could be anything. So straight away that one doesn't really make sense, but let's take a look at parallelogram. So parallelogram has two sets of parallel sides that are congruent. So that's a parallelogram. Also, you could squish it a little more or stretch it. So it's saying opposite angles. Well, this angle and this angle, should they be congruent? And yeah, they should. These are parallel lines, and in a way, this side is almost like a transversal in a way. So these are opposite and equal, and also change color. The other two opposite angles are also congruent. So our answer here is parallelogram. That's our answer for 105. Okay, 106. Consecutive angles are... Now, first of all, let's just figure out consecutive, because consecutive numbers are 1, 2, 3 numbers in a row, or consecutive even numbers, 2, 4, 6. So numbers in a row. So when we're talking about consecutive angles, what we're really talking about, and it could be any shape, talking about angles that are next to each other. So this and this would be consecutive, or 5 and the 1 would also be consecutive, or 4 and the 5, just right next to each other, they're consecutive. So consecutive angles are blank in a parallelogram. So let's take a look at a parallelogram again, kind of like this. So this angle here, and let's just say this angle here, they're both consecutive. Well, I see that the top one is obtuse and the bottom one is acute. It says are congruent. Well, then they're not the same. Congruent means exactly the same, so it must be supplementary, and supplementary means that they sum to 180 degrees, and that is in fact what they do in a parallelogram. Consecutive angles are supplementary. So I'm just going to put sup there. Okay, that was question 106. 107, right here, a blank is always a rhombus. Well, a rhombus, let's think what it is. It has two pairs of parallel, oops, got an extra E in there, two pairs of parallel sides, and also all four sides are congruent. So a rectangle, the four sides do not have to be congruent, only two of these. So in fact, rectangles are types of parallelograms, whereas a square, if we just give it a push on the top, it does give us a rhombus. So a square is in fact a rhombus because it meets these things here. It has two pairs of parallel sides and all four sides are congruent. The only difference between a square and a rhombus is the fact that all of the angles are 90 degrees, and that's the same here. The only difference between a rectangle and a parallelogram is that all of the angles are 90 degrees. So this one would be square. Alright, 108. So this is a rectangle, so we know that there's 90 degrees, 90 degrees. We're told right here, ADC, A to D to C, which is here, is 40x plus 10. Let's change color. Blue, we're told DAB, D to A to B right here, is 15x plus 35. Now, we've got to think, do we add these together and it gives us some number 180 or whatever, or are they complementary, are they supplementary? And really one way to look at this, or to remember it, is that these two angles here and back in red right here are the same as this angle here and this angle here. They are alternate interior angles, and we know that alternate interior angles are congruent. So this telling us it's a rectangle tells us that this bottom segment AB is parallel to CD, and knowing that they're parallel tells us that these two angles are in fact congruent. So what we can do is set up our equation. 15x plus 35 equals 40x plus 10. So now what we're going to do is we're going to get all the x's together, all of the numbers together. So I'm focusing where are my x's. I focus on the smallest coefficient of x, that's the number in front. Coefficient's 15 here, 40 over there, so let's subtract the whole of that, minus 15x. So they've gone from over there, 35 comes down, this gives us 25x plus 10. Now it's a two-step equation. Subtract 10 from both sides. It's gone over here, this gives us 25 equals 25x. So when we divide both sides by 25 to get the x on its own, we end up with x equals 1. And that's what our question wanted up here. I might just turn it around, make it a little more obvious. X equals 1, and that's 108. Alright, question 109. So in this question right here, we're told this is a rhombus. So straight away we know that this equals this, equals this, equals this. However, we don't know that all these angles are the same, because they're not. What we do know is that opposite angles are equal. So these two ones in red are congruent, and these two in blue are congruent. And we also know that if we take this one and this one together, they would sum to 180 degrees. Likewise, this one and this one would sum to 180 degrees, and likewise right here, 180. So consecutive angles are supplementary. So let's take a look at what we're trying to find. We're trying to find the measure of angle URS. So URS, let's try and find that. U to R to S. So that's right here. We are trying to find this angle. And we know here it's labeled as 2x plus 10 right here, URS. And we know that RUT, R to U to T, which is right here, is 10x plus 14. So what we just said here is actually pretty important right now. And this is, we're able to solve this right now because we know a fact about a rhombus. We know that consecutive angles are supplementary. So we can take one of them, the 10x plus 14. Let's add the 2x plus 10. So we've taken this and we've taken this, we've added them together. And because they're supplementary, we're going to let them equal 180 degrees. So next step, we're going to combine like terms. We've got 10x plus 2x, which gives us 12x. We've got 14 plus 10, so that's plus 24 equals 180. Next step, I'm going to subtract 24 from both sides. It's going to disappear over here. We're left with 12x equals 156. So now when we divide both sides by 12, I've got x equals, now I know 12 goes into 144 12 times. This is one more, so that's 13. X equals 13 here. Now we can't stop at this point and just think we're done. It would be very easy to make a big mistake right now. That's not our answer. Although we have x equals 13, we were told to find the measurement of angle URS. Now URS is right here. It's 2x plus 10. So if we know x is 13, we plug that in, we substitute it, 2 times 13 plus 10. Well, 2 times 13 is 26 plus 10 gives us an answer of 36 degrees. So the measure of angle URS is 36 degrees. Okay, question 110. So again, it's parallelogram, so let's label what we know. This equals this, and also this side equals this side. Or really not sides, they're diagonals, or half of the diagonal. This is the midpoint right there. So here it says find EM. So I'm guessing E should really be the name of this point right here. That's E. So let me label it a little closer. Let's see. So in this case, we're given WM, which is this entire thing. W is right here to M, which is right here, and that's 22x minus 32. E lives right in the middle, and we're told W to E right here, which is different to this other dimension, WE equals 3x plus 8. So because we know it's a parallelogram, and we know this equals this, we now know that if we take the 3x plus 8 and double it, times it by 2, that should give us the whole length, which is 22x minus 32. So now it's a multi-step equation. Let's distribute this side. 2 times 3x is 6x. 2 times the 8 is 16. Alright, so now I'm going to continue usual way, subtract the baby x from both sides. We end up with 16 equals 16x. Let's make sure I'm doing this right, minus 32. So now I got to get the x's on their own, so I'm going to add the 32 to both sides. That now gets me closer. 16x equals 48. So now when I divide both sides by 16, I end up with x equals 3. Now, again, that's not my final answer. That's almost there. But so we have x equals 3, but we're asked to find EM. So if EM is the middle right here to the outside, EM is right here, and we know that EM is the same as 3x plus 8. 3x plus 8, and we know that x equals 3. So that's 3 times 3 plus 8. Oops, no need for that extra parentheses right there. 3 times 3 is 9, plus 8 is 17. So 17 would be my answer for question 110. All right, 111 tells us that this is a square and it wants x. Well, let's take a look. X is trapped here right now, and we're told a statement, the measure, or in fact angle, SMA. So S to M to A is right here, this angle right here. And we're told this equals 15x minus 30. Well, the thing is, when you have a square, and the same with a rhombus, square or a rhombus, when you have one of these shapes and you take the two diagonals, they create right angles in the very center. So this is an example with a rhombus, and same example with a square. When these diagonals intersect, they give you 90-degree angles in the center. So we know that this angle is in fact 90 degrees. Setting up our equation, 15x minus 30 equals 90. So when we start to solve this, we've now got 15x equals 120. When we divide both sides by 15, we end up with x equals, I'm pretty sure it's 8. 5 into 15 goes 3 times. 5 into 120, well, 5 into 100 goes 20. And then there's another 20, and 5 goes into 24. So that's 24. 3 into 24 is 8. So that is our answer for 111. Okay, question 112. So we know this is a parallelogram. So straight away, if we know this is a parallelogram, we know these two are parallel. And we also know that these two here are also parallel. But we know that the top two sides, top side and the bottom side, are congruent, and the left and the right are congruent. So here it wants to know the length of AB. The only thing that we have to go on is we have the bottom side, and because we know they're equal, we can set up our equation. So baby x is over here, minus 3x from both sides. The x's have gone. 9 equals 5x minus 41. So now let's add the 41. This is going to make the numbers a lot nicer right now. So 5x equals 50. So probably guessing by now that x equals 10. Now this isn't our final answer. Again, always look back to the question and ask yourself, did you answer the question being asked? This one wants to know how long is AB. So when I look back up here, I see that AB equals 3x plus 9. We found x to be 10. So we got to go back in there. 3 times 10, 30 plus 9 equals 39. So we know that length of AB is 39. This is our answer. And if we didn't do it, we would lose points. We don't want to lose points. All right. Next question, 113. So here it says, given that PQRS is a rectangle, so again, we know things like 90 degrees. We know that this equals this. We know this equals this. It says PR, P through R, which is, let me change color because that's a diagonal. P through R. Oh, let me actually use a straight line. I can't go straight with that. So PR right here, it tells us that this distance is 8x minus 10. And we know that SQ, which, let's draw that one as well. Let's go for pink. S through Q, which is this over here, and that distance is 2x plus 38. And it wants to know the length of PR. Well, not only does it look like it, but this is another definition of rectangles, that these diagonals are in fact equal. So we can let 8x minus 10 equal 2x plus 38. So now when we start to solve this, we look for the baby x, which is the 2x. Let's get rid of that first. So you end up with 6x minus 10 equals 38. Let's add the 10 to both sides. So here we end up with 6x equals 48. When we divide both sides by 6, we end up with x equals 8. And so let's check back. We needed the length of PR. We know that PR equals this. So 8 times x, x is 8. 8 times 8 minus 10. So that gives us 64 minus 10. So the answer is 54. PR equals 54. All right, next question, 114. In this question, we are asked to find KL, which is along the top. We're told it's a rhombus. So we know this equals this equals this equals this. We also know that these are 90 degrees in the middle. And then we also know, let me change to orange, we also know that this equals this, and this right here equals this right here. So KR is 5, so let's change color. This right here is 5, so we know this is also 5. We know RL is 12, so this is also 12. And it wants us to find KL, which is right here. So the trick is, even though we're given a quadrilateral, a rhombus, the trick here is seeing that there is a right triangle in there with sides 5 and 12, and we need the distance between K and L, which just for this example, let's call it X. So now we're going to go to the Pythagorean theorem. A squared plus B squared equals C squared. So that's 5 squared plus 12 squared equals, in this case, X squared, because we've called it X. So this is 25 plus 144 equals X squared. When you add these together, you get 169. Let's square root both of these. That gives us our X on its own, which is really the KL, and that is 13. So now we could say that KL equals 13. That is 114. Okay, 115 and 16 on this slide. So find the missing side length, use your formula sheet for reference. All of the following triangles are right triangles. So because they've given us that information, we know these are both right triangles. So therefore, 8 squared plus 6 squared equals X squared. So in this case, 64 plus 36 equals X squared. So that's 100 equals x squared. When we square root both sides, we end up with x equals 10. Okay, so question number 116. X is our hypotenuse, so we can start the equation 5 squared plus 7 squared equals x squared. This would be 25 plus 49 equals x squared. When we add these, we get 74 equals x squared, and then of course we'll undo by square rooting. So we end up with x equals radical 74. Now at first you've got to think, well, is 74, does it have any perfect square factors? So perfect square factors are 1, 2, let me undo that, 1, 4, 9, 16, 25, and so on. So this is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, etc. And so I know 74 isn't prime because you could write it as 2 times by 37, but then 37's prime. So when I start to think about other factors that are in there, I can't, 1 won't help us. I can't think of any of these other perfect squares that would go in there. And so this is the simplest radical form. This is also the most precise answer. If you were asked to round it to the hundredths or the tenths or even the hundredth place, you could then go on to use a calculator and say x equals whatever it does, but you would actually use your wavy signs and you would say to the hundredths or whatever it is. Okay, so that was number 116. Okay, 117, let's take a look. So here, this time around, this is your hypotenuse. So we've got x squared plus 16 squared equals 20 squared. So now when we start to solve this, 20 squared is in fact 400. 16 squared is in fact, what is that? 16 is 256. So we're going to write the x squared right there. Now we're going to subtract 256 from both sides. And so this leaves us with 144. X squared equals 144. When we square root both of these, it becomes pretty clear that x equals 12. So that's our answer here. Okay, so in question 118, a couple of things make this a little trickier. I'm going to assume the right angles right here. One thing is that we have a radical as the hypotenuse. The next thing is, in the previous questions, we'd had 2 legs and the hypotenuse labeled, or one of them was missing. In this case, we don't know what one of the legs is, and it's not even a variable that we can find. But we do have an angle. So when this is the case, well, we're using angles to help us try and solve these problems. We need to use the trigonometric ratios. And so those are used when we can figure out SOHCAHTOA. Now SOHCAHTOA is a mnemonic that helps us remember that the sine of an angle equals the opposite over the hypotenuse. The cosine of an angle equals the adjacent all over the hypotenuse, and the tangent of an angle equals the opposite over the adjacent of an angle. So in this case, we have an angle right here. The opposite is what we're looking to find, so we've got an opposite there, and we also have the hypotenuse. So when we're dealing with opposite and hypotenuse, the ratio that we're going to use is the sine. So sine 45 equals the opposite, which is x, all over the hypotenuse, which is 5 radical 2. So now, to get the x on its own, we're going to multiply by 5 radical 2 on both sides, radical 2. Now at this point, I'm not even using my calculator yet, but I'm just labeling all this stuff. So 5 radical 2 times by sine 45 equals x. So now I would plug this into my calculator, make sure that my calculator is in degree mode and not radian mode, and when I plug all this stuff in, I get the answer of 5. So in finding x, my answer would be 5 here. Okay, 119 right here. Okay, so again, we are assuming that these are right triangles. In this case right here, I have 3 sides, so it's the Pythagorean theorem. And I'm noticing a couple of things though. Even though we have 3 sides, we have 2 variables, and so there's 2 missing. So this looks pretty impossible. Our Pythagorean theorem is a squared plus b squared equals c squared. Even if we plug this in, y is the hypotenuse, so y squared, x goes there, and 8 squared is there. So as far as we can get is just 64 plus x squared equals y squared. There's nothing else we can do to go on to solve this when we only have the one variable. Okay, so this is question number 120. This is the last one in the packet. In this case, we are to use SOHCAHTOA. The trigonometric ratios, we have our hypotenuse here. This is directly opposite the right angle. We have the angle that we're given here, 30 degrees, which would make this right here the adjacent next to. This one right here would be the opposite. Now, one thing that we need to make sure we don't forget is that the original question here told us to find all missing angles. So, in fact, we've got to find 2 angles here. So for x, we have the adjacent is part of this, and also the opposite. So the adjacent and the opposite would be TOA. So first of all, tan 30 equals 7 all over x. When we're now to try and get x on its own, we would times both sides by x. This would give us 7. X tan 30. And then to get the x on its own, we would divide by tan 30. And in this case, we would take our calculator, do 7 divided by tan 30, and we would in fact get approximately 12.1. This is rounded to the tenths because this number continues. Alright, let's change the color to red to try and find out the value of the y now. So in looking at y, we have the angle, the hypotenuse, and let's use the 7 over here, which is the opposite. So when we're dealing with the opposite and the hypotenuse, we're dealing with sine. So sine of 30 degrees equals 7 all over y, times by y, times by y. So therefore y sine 30 equals 7. Divide both sides by sine 30. And this would leave us with y equals 7 all over sine 30. And when we grab a calculator, the answer to this would be exactly 14. So 14 would be our final answer for the missing value y. This is the end of the 5-part series. Now it's been a lot of stuff for the final midterm that we'll be taking in a couple of weeks. Some content that hasn't been covered too well here are constructions of parallel lines, perpendicular lines, equilateral triangles, isosceles triangles. Also, not just constructions, but proofs, and finally transformations. So make sure to study your notes in those areas, and I'll try and put some shorter videos up to cover those topics too. Many thanks.